How can you check the sensors and thermistors? How can you use the same values to check if either sensor is faulty or PCB? So, let's get started. As you see, I've kept the required tools at the table, which are sensors, thermistors, hot and cold water, digital temperature sensor through which we can know about the temperature values, and some multimeters. See, we have different types of multimeters. It's an analog meter that is very useful and used for various purposes. These are digital meters and clamp meters through which we check ohms, mega ohms, and kilo ohms. All meters are used for the same purpose. It's a different topic we will show you. So now we put it aside. First of all, we talk about the types of sensors, because here, your life will change when you understand the system of sensors and what is its principle of working. When you learn the basics, whatever brand comes in front of you and whatever the system is, you can check these sensors quickly. Then you will be able to remove its fault precisely. Let me tell you, it has two types, one is NTC, and the other is PTC. So first, we talk about NTC, its mean negative temperature coefficient. How to know the presence and cause of NTC and PTC in system. NTC resistance and the value fall when the temperature is high. In another case, when the temperature goes down, the value of NTC is high. That's why we called NTC sensors. PTC means positive temperature coefficient. In PTC, when the temperature is high, the resistance of PTC increases, and when the temperature falls, the value of PTC drops down. The NTC sensor works differently than the PTC sensor, and both are used for different purposes in different systems. In addition, they are installed in electronics for various purposes. So always remember this, then you will memorize the NTC and PTC sensor difference excellently. Now, if you have understood the types of sensors and their working principles, then let me now tell you how to test these sensors, because if you learn how to test them, you can check any sensor, and after checking its value, you can identify whether the sensor is bad or okay. So let me tell you this method as well. Now let's check the sensor. See the tools I showed you before, and I have these sensors, which I will test. The sensors are always of different values. You can see that this sensor is 62.4 kilo ohms. I have placed all the same valued sensors in a packet. See, this is 4.87 kilo ohms, 13.15 kilo ohms, and 22 kilo ohms. The purpose of showing you these sensors is if you install a faulty value sensor or a high or low valued sensor in a place of the required value. For example, most of the coil and room temperature sensors are 4.87 kilo ohms. I am just giving an example. If you install a 62 kilo ohm sensor in place of 4.87 kilo ohms, the sensor will never work and show errors. So you have to check this, and I will also tell you its method. Always remember these sensors has a link with the temperature. For example, it's winter, and you are checking the sensor, then the value of the sensor will be whether it is a PTC or an NTC sensor. And when you are checking the sensor value in the summer, always remember the principle of the NTC and PTC sensors, so it could be easy for you to check the thermistor. Then you can check the sensors without wasting time and any certified technician required at your home. Now let me teach you how to check them. I have told you about these sensors, so let me keep these sensors aside. I have made this setup for checking the sensors. I have placed hot water and cold water. I will turn on the multimeter. The current temperature is 34.6 degrees Celsius, which is detected by this temperature sensor. I will put the temperature sensor inside the cold water. Now the temperature sensor will work, and the temperature will change. Now I am showing you the principle of NTC and PTC sensor I told you, and let's see whether it works or not. The temperature on the temperature meter has changed to 14 degrees due to cold water. I have this pipe coil sensor generally used in different electronics appliances. Before putting the sensor in cold water, let's check the value of the NTC sensor at room temperature. The room temperature is 35 degrees. So the sensor is showing 3.521 kilo ohms at 35 degrees Celsius. Always remember ohms, kilo ohms, and mega ohms. It is another subject I will teach you in my upcoming videos. So this coil sensor is showing 3.521 kilo ohms at room temperature. I have put the sensor inside the cold water and see 11.2 degrees Celsius shown on the temperature sensor. So now, we will check what value it shows on the multimeter. See, the resistance of the thermistor has started to increase. So it is an NTC sensor because it is working on the principle I told you. As the water temperature is lower than the room temperature, the sensor's resistance increases. Now we know that it is an NTC sensor and is working fine. Now the resistance value is at 8 kilo ohms. If you keep lowering the temperature of the water, the resistance will keep increasing in the sensor. And the PCB or circuit will keep sensing it. Now I will check the sensor inside the hot water. The room temperature is still 35 degrees Celsius. See, I have put the temperature sensor inside the hot water. After that, the temperature sensor will show us the hot water's temperature. The temperature of the water is 44 degrees Celsius. When I check the value of the sensor, it shows 3.6 kilo ohms at 35 degrees Celsius again. Now I am putting the sensor inside the hot water. And now, let's check the value of the sensor at 47 degrees Celsius. The resistance value of the NTC sensor should drop than the room temperature value. See, the resistance value has started to drop, which is 2.4 kilo ohms. So the sensor will work as a wire if we increase the temperature by more than 47 degrees. So it is working fine on the principles of sensors, which means now we are confirming that this is an NTC sensor. Friends, the demonstration I showed you is of the pipe coil sensor. You can check the room temperature sensor the same way, not even this. You can check any sensor this way. The PTC sensor can also be checked with the same method, but their principle will be different, as I have no such kind of sensor, so I cannot demonstrate it. But the method of testing is the same, only this will be the difference in principle for the PTC sensor, that the resistance value will increase when the temperature rises. But, conversely, when the temperature gets low, the resistance value of the PTC sensor will also drop. This will be the principle for checking the PTC sensor.
In my veins, I've been driving this train. Years in this lane, there's no stopping this flame. Cause I came to the game and I changed it to play how I like, rearrange